So in this UTME problem, let me show you how to solve this particular problem. Of course, if I want to make decision on this, I will just choose option C. But why should it be option C? Why not one option B or A or D? And most likely a lot of students will also want to choose C. Some may not even have an idea why should it be C or why it is C. So let me show you real quick. Now the question says the number of unpaired, that's the key word there, unpaired electrons in a ground state. Look at another concern here, a ground state nitrogen. So we're going to be working with these two information that is attached to the whole of this. So the first step is to determine the atomic number of nitrogen. If you check on your periodic table, the atomic number of nitrogen is 7. And I believe a lot of you will agree to that. If you don't know how it happens, go and check your periodic table, because I want to make this video as short as I can, as short as possible. So this means if I have the atomic number of nitrogen to be 7, it means the proton number of nitrogen will also be 7. The proton number is also 7. The electron number of nitrogen, electron number is also 7. It is from this electron number you can also get what we call the electronic configuration. I believe you know about the electronic configuration. Some of you still don't know about the electronic configuration. Go and watch my video on YouTube. Instructor Allison's tutorial, that's my YouTube name. Go and learn about these things. Okay, so but then I have to also tell you why is the proton number 7, why is electron number 7 for this particular nitrogen? Could it be that anytime we see an element whose atomic number is a particular number, it means the proton number and electron number is 7? That's a very key question I expect any of you to ask. But then I've asked the question, I'm going to be answering the question. All right, but just keep in mind that the atomic number of nitrogen is 7, proton number is 7, electron number is 7. So now what will be the next thing? We need to arrange this particular number. We need to arrange, since we've known the the electron number of this particular nitrogen to be 7, then what is the electronic configuration of this particular one? So what is the electronic configuration of nitrogen? We have the half-Bohr principle. There are 3 chemical principles we need to be familiar with. We have the half-Bohr principle, the polar exclusion principle, and the Hund's law of maximum multiplicity. So let's use the half-Bohr principle, the build-up principle. The electronic configuration, since it is 7, we have 1s2. Remember, this s shell can take maximum of 2 electrons. The next one is going to be s2s2. We have gotten 4 electrons, remaining 3. So we need to move to the next one, which is 2p. P can take maximum of 6, but we just need 3 electrons, which is just 3. If you sum up this, that gives you 7. So this is the electronic configuration of this nitrogen. Remember, they mentioned something, ground state nitrogen. The reason why I said for an atomic number of nitrogen is 7, that means the proton number is 7, electronic number is 7, is because of this statement, ground state nitrogen. What does this thing mean, ground state? It means it is free state. Another name for ground state, you can use free state. That means the free state of nitrogen is 7. If you don't want to use, when I say free state or ground state, it is when it has no charge. When there is no charge, it doesn't have any charge. It has not been charged. This nitrogen has not been charged. When it has not, it doesn't have like anything, like it does not engage in any kind of reaction. That's when we call it ground state. And anytime you see an element in its ground state, then it means that atomic number of that element is still going to be the proton number, and it's still going to be the electron number. I hope this helps. Normal state. When I say ground state, normal state. I hope this helps. I hope you understand that particular point clearly. Okay, so now we've gotten the electronic configuration of this nitrogen to be this one. So let's show the arrangement of these electrons in their respective orbitals. That's when you consider the other rule that I mentioned, polar exclusion principle. From polar exclusion principle, when you talk about the one s2, that means you see that these two will have an opposite spin, the spin up and then spin down. It must be in opposite direction. You must not have them presented in the same direction like this. No, that's not what this polar exclusion principle wanted to do. So we've solved for this particular. What about this 2s2? This 2s2, remember, is still the same thing. We have it in opposite spin, which is like this and also like this. On this particular third one, which is, let's use this particular point, we have 2p3. So we get it in this form. For this 2p3, this is called degenerate. Have you heard of that word, degenerate? degenerate, or some people call it degeneracy. This is a degenerate orbiter. Now, why do I call it degenerate orbiter? The meaning is that it has more than one subshell. So meaning they possess or um sharing the same energy level. That's what it means. We use the Hunts rule to feed this particular one. I don't want to say much story because this video is getting longer. We use the Hunts rule to work on this particular one. And what does the Hunts rule state? Hunts rule says that electrons should fill into orbiter singly first. Electrons should fill into this electron. They should fill in this thing singly. That's 1 1 first before pairing in a degenerate orbital. So that means for this 2p3, I will have this fill in singly first, 1 2 and 3. So let's say if this were to be 5, then after I fill the first one, second one, third one, I will have to fill another one in opposite direction, another one, that makes it 5. Then I will just say this is the only unpaired electron, because they say the number of unpaired electron, that would have just been 1. But in this case, it's 2p3, so we have this one. This is not paired because you don't have the second one here. This is not paired. That's first. This one is not also paired. Second, this one is not also paired. So the number of unpaired electrons is just 3. That's why we chose this particular 3. I believe this helps, and if you found this particular one helpful, please make sure to share this particular video, like and comment. Make sure to share this particular video. I know I didn't use pigeon to teach this one, but I believe you also understand from that. Share this particular video. Thank you for watching. See you next one. Bye.